Hi, Kubernetes deployment models for high availability. In this section, we will demonstrate Kubernetes architecture and design principles and best practices. We'll cover strategies for achieving a highly available, geographically redundant Kubernetes deployment architecture, including federation. We'll learn some ideas for scaling Kubernetes and some key vertical limitations of the platform. Kubernetes architecture and design. In this video, we will demonstrate Kubernetes conceptual and component architecture. We'll explore the Kubernetes logical master-slave architecture, and we'll get an overview of a production-grade Kubernetes deployment in an enterprise environment. Let's go over some key terms for Kubernetes. The first key term we want to learn is the Kubernetes object. It's a very key term. So Kubernetes objects are a record of intent. So it's a record of intent. Once created, the Kubernetes system will constantly work to ensure that objects exist. Kubernetes objects are persistent entities in the Kubernetes system. Kubernetes objects are used to represent the state of your cluster. So Kubernetes objects describe what containerized applications are running and on which nodes, the resources available to those applications, and the policies around how those applications behave, such as restart policies, upgrades, and fault tolerance. Kubernetes objects can be defined as a YAML configuration file with two main parts. They have a spec and a status. So if you really want to know what a Kubernetes object is, typically we store them as YAML configuration files. So we'll have like a deployment, a myapp.deployment.yaml file, or a myservice.yaml file, or myappservice.yaml file. So, and in these YAML files, the structure, and part of the structure is the fields needed are the spec and status fields. So object, spec, and status. Kubernetes objects include two nested object fields that govern the object's configuration, the object spec and the object status. The spec, which you must provide, describes your desired state for the object, the characteristics that you want the object to have. And the status describes the actual state of the object and is supplied and updated by the Kubernetes system. So the status part is not something that we would actually specify in any of our YAML configurations, but we'll always usually specify a spec. So there's different types of objects, right? So there's like deployment objects, replica set objects, controller objects, there's these pod objects. The first thing, the most fundamental one we're going to start with is the pod object. So a pod is the smallest and simplest Kubernetes object. The pod represents a set of running containers in your cluster. So a pod can have one or more than one containers, but usually the best practice is to have one unless you really need more than one. Such as an example is two containers that are tightly coupled and they should be in one pod, but otherwise it's usually one container per pod, or like one Docker image per pod. A pod is typically set up to run a single primary container, so it can also run optional sidecar containers again that add supplementary features like logging. Pods are commonly managed by a deployment definition object, so the next object we're going to talk about is the deployment object. In the deployment object, it describes the desired state. A deployment controller changes the actual state to the desired state at a controlled rate. So maybe 30 seconds, maybe every 5 seconds, Kubernetes will maintain its state. We can define deployments to create new replica sets or to remove existing deployments and adopt all their resources with new deployments. What is a replica set? So a replica set ensures that a specified number of pod replicas are running at any given time. So the replica set is how we handle scalability in Kubernetes for our applications, application level scalability. So a replica set provides a mechanism for us to define the number of app instances that we would like to maintain, constantly maintain. A replica set should be defined within a deployment object rather than being manipulated directly. And a replica set provides declarative updates to pods. So the key thing here about the replica set, within our deployment object, we will specify two things. We can specify a pod template or pod object, but we'll also specify the replica field. And when we create the deployment and we create the replica field, the replica set automatically gets created for us. So we don't act, just in case you're curious, how we specify how many app instances we want or container pod instances we would like. We specify that in the replica field of our pod spec, and essentially the replica set gets created for us. Kubernetes service objects. A service is an API object that describes how to access applications such as a set of pods. A service is an abstraction which defines a logical set of pods and a policy by which to access them, sometimes called a microservice. The Kube proxy in each worker node is responsible for managing virtual IPs for the service. So the service, so imagine we're in the scenario where we're in the enterprise, we're in an industry environment, and we just created Hello World Web Service or some other actually important web service like a user service. And it's a RESTful web service, and and we've containerized and it's been deployed, and there's multiple instances of these containers and pods, and we want to give this a common URL and to load balance between these pods, and this is kind of what a service is. It exposes a common URL for this set of pods. And there's all sorts of rules we can configure for this. So the Kubernetes component architecture. The Kubernetes node, or K node, it's a worker node that participates in a Kubernetes cluster. It's usually implemented as a virtual or physical host, and it runs a kubelet that communicates with the master node. So as this little arrow is pointing down here, the Kubernetes minions, these are actually called, term minions has been deprecated. The new term is K node. So each one of these little boxes you see is a K node, and each one of these little boxes running a kubelet, which is what defines that it is K node, because the kubelet communicates with the master. The Kube-Apiserver is the primary component of the master node. It exposes a REST API that we can post the Kubernetes objects to. So like if you want to create a pod or a deployment, that's all. To create those, we make REST API calls to the Kube-Apiserver. Finally, when we do this through the Kube command line tool, kubectl, the kubectl is actually making REST requests to our Kube-Apiserver. It's pointed to it. So when you use like a create pod or create deployment, it's actually making the corresponding REST API call to the Kube-Apiserver. And all those API objects that we post, they get stored in this etcd data store. etcd is a highly available key value data store used by Kubernetes to store all of the API objects that we create via the kubectl command line or by calling the Kube-Apiserver. The kubelet is the primary node agent that runs on each node, and it talks to the master. So the kubelet takes a set of pod specs that are provided through various mechanisms, primarily through the API server, and ensures that the containers described in those pod specs are running and healthy. And a pod spec is a YAML or JSON object that we post it to the API server. It's a description for a pod.